Okay, so this is the second lesson in the trigonometry unit, Applications of Trig 8.3. So this is the first of 2 days where we're going to do word problems. So these word problems can get a little bit hairy. So again, the list of homework questions does have quite a few questions. Please try to do as many of the homework questions as you possibly can. Okay, so there are some instances where you're going to be given the diagram, some where you need to draw your own. And again, make sure that diagram is labeled. As usual, you want to make sure you have a let statement for word problems, show all of your work, and then make sure you have an answer statement, especially in a case where maybe you have to like add X and Y together or something in order to get your final answer. Okay, so this one isn't so bad. We're just going to solve triangle ABC, given that AC is 4 centimeters, BC is 5 centimeters, and angle B is 90. Again, this was in the lesson, the first lesson 8.1, but when it says solve the triangle, that means you're solving for all sides and angles. Okay, so there you can draw your triangle however you want. And again, I don't have a ruler on this. Do a better job than me. It does say that angle B is the 90. So that is important. And then you can choose to do whatever letters you want, or you could put A down in the bottom and C at the top. I've chosen to draw mine like this. So it says that angle or side AC is 4 centimeters. So that's this side. And then BC is 1.5. So since AC is the hypotenuse, then it should be the longest side. Angle or side AC should be the longest side, the hypotenuse. Okay, so you now have quite a few options to solve for this. If you like the Pythagorean theorem, you could do that. Or let's use SOHCAHTOA to make sure that we are understanding 8.1. So now when you do the Pythagorean theorem, you need to remember that the side C in the official Pythagorean theorem is the hypotenuse. Okay, so if you're going to use that, which is fine, then make sure that you're doing that there. Okay, so what I'm going to do is I'm not going to use the first I'll use SOHCAHTOA, and then maybe we can see what the Pythagorean theorem is going to give us. So right now we only know the angle for the 90 degrees, angle B. So maybe that's somewhere we can start. We have to solve for all the angles, angle A and angle C, so it doesn't really matter. So which one you start with? This is the hypotenuse, the 4. Now it depends on whether we're going to start with angle C or with angle A, what the 1.5 is. So if you have a favorite ratio, like if you prefer sine over cos, then if you do A, 1.5 is opposite. If you do C, 1.5 is adjacent, but it doesn't really matter. Maybe I'll just go in alphabetical order. Okay, so I'm going to solve for angle A, which is here. So that means that the 1.5 is going to be opposite. So now we've got opposite, we've got hypotenuse. So we're going to use so. Sine is opposite over hypotenuse. You can put theta if you want, or you can put A. When we do angles, we use capitals. When we do sides, like in the Pythagorean theorem, we use lowercase letters. And that's going to continue when we actually get to the sine law as well. So if you want to start using that notation, then that is perfectly reasonable. Okay, so sine of A is opposite over hypotenuse. And then we need to solve for that. So it's up to you if you want to divide or you want to just do the inverse. Okay, so that is angle A. So now if you want to go back up into your triangle and put in what angle A is, because that can help you. So now when we solve for angle C, then you can actually do a shortcut, right? Because all of the interior angles need to add up to 180. So 180 minus 90 minus 22 gives us 68. You could have also used cos, right? Because the adjacent side is 1.5. You could have used cos C and done it that way as well. But it doesn't really matter. So now our last thing we need to solve for is side AB, or again, depending on what angle you want to use. Then if you use angle A, it's going to be the adjacent side. If you use angle C, it'll be its opposite side. Okay, so just be careful of what you are doing. So we'll solve for that one. Okay, you could use the Pythagorean theorem as well, but I'm just going to stick to SOHCAHTOA so that you get practice with the 8.1 again. Okay, so I'm going to do cos this time, so I'm going to stick with angle A. So now when I do angle A, then the side we're looking for is the adjacent side. And then you could actually use, we could use tan. It doesn't really matter. Okay, so I'm going to use cos. Okay, so now we are going to get the adjacent by itself. If you don't like that, you want to call that adjacent side x, you could do that, and then you're solving for x basically. The unknown here is the adjacent side, so we have to get rid of or cancel out the 4 on the adjacent side there, and we're doing 40 times cos 22, which is going to give us 3.7.
I don't know where it is. Mommy, I can't really move it on.
Well, go look where you were sitting and having your cheese string.
Okay.
Sorry about that. Okay, so now this example, we have to draw our own triangle, and it's a little bit trickier about what you're going to do. So we have the distance between 2 floors in a new home is 2.5 meters. Okay, so at first it might seem strange. Like if you have 2 floors, they are horizontal, right? There's no triangle there. So we're going to draw our triangle in between. So it says the distance between the 2 floors is 2.5 meters. And then the horizontal length of the staircase is 2.8 meters. So you really need to think what a staircase is. Is a staircase straight up and down? No, it's not. It sort of goes on an angle, right? So this is going to be the staircase to the next floor, and it says the horizontal length is 2.8 meters. So now we are looking for 2 different things. We are looking for the slope of the staircase and the angle of inclination of these stairs. So the slope is we're looking for the horizontal length of the staircase is 2.8 meters, and not the angled length. The horizontal length of the staircase is 2.8 meters, and we are looking for the slope of the staircase, or the rise or the run, and we are looking for the angle of inclination. So if you think about, if you're going up, like these are the stairs here, terribly drawn in, then that means the angle of inclination of the stairs is how much is it going up, then that's the angle we're looking for down here. We'll talk a little bit about angle of depression in the next example. Like you could look at how the angle going down, but we'll do that next. Okay, so slope is rise over run. So the rise here is 2.5 and the run is 2.8. And then the next one is more like a traditional word problems. What is the angle of inclination of the stairs? I use the symbol theta. And if we label the triangle, so we have, if we're going to use this theta, then this side is adjacent and this side is opposite. So we have opposite, we have adjacent, which means we're going to use tan. Okay, so again, you can choose to do the inverse tan and leave the 2.5 over 2.8, or you can change it. And then to get theta by itself, you have to do tan inverse. Your calculator might also have an answer button, which you can use instead of retyping in the number every time. But again, that would require that you had a pretty good knowledge of your calculator. So if you don't know how to use your calculator, don't try to use shortcuts, okay? So now we have the angle of inclination is 41.8, and then because it's a word problem, we're going to write an answer statement. Okay? All right, so a different type of question you could be asked is angle of elevation and angle of depression. So usually these terms we use to describe something with relation to the horizontal. So it's often discussing, like, you can see the person standing on a cliff, and then there's a helicopter or something in the air, and then a sailboat or something below it. Okay, so if you think about depression is like low, so then you're going below the horizontal. So horizontal is this line here. Vertical would be up and down. So we're always comparing to the horizontal, and then you draw your triangle in. So if you're going to do the angle of elevation, then you go up to the helicopter, and then again, now you've made a triangle. When you do angle of depression, you would go down, like depressed, and then again, draw that in, and now you've got a triangle, okay? So a search and rescue airplane is flying at an altitude of 1,200 meters towards a disabled ship. The pilot notes the angle of depression to the ship is 12 degrees. How much farther does the plane have to fly to end up directly above the ship? Okay, so we've got these are, pictures here, but let's just draw a triangle. So I'm going to use P for plane. So the plane is it wants to be directly above the ship. So you can assume that it's not directly above the ship. And why is it directly above the ship? Because then we're going to get a 90-degree angle. Okay, so when you do this, put your ship in somewhere. Okay, and then the plane is going to fly some sort of distance to be about right above the ship. So again, you get that 90 degrees and then complete your triangle. Nicer than I did. Okay, so now it says, the pilot notes the angle of depression to the ship is 12 degrees. So this is where it can be tricky. What are we doing? So you want to do from the pilot or the plane here, and then the angle down to the ship. So we're talking about this angle in here. It's not talking about what's the angle of the ship with respect to the pilot. We're doing the pilot to the ship. Okay, so that's the angle we're using, which is 12 degrees. And so it says, how much farther does a plane have to fly to end up directly above the ship? So again, we're not going to the ship. We're going to fly directly above it. So we are looking for this side here. Okay, so we've got the distance to the ship directly above it. That's our X. We're not trying to fly to the ship. Now you might ask yourself, why would we fly directly above it? Maybe they're going to put a rope down, who knows? Okay, so that's not really what we're asked here. We just want to get directly above the ship. It says it is flying at an altitude of 1,200 meters towards a disabled ship. So the pilot is 1,200 meters above the ship. Okay, so now let's label our triangle. We're going to use this theta. So this side over here is opposite. We are not finding the side directly across from the right angle. This is to theta. This is the side beside it, or the adjacent side. So now we have opposite and we have adjacent, which is tan. So I'm going to use the X there. So then again, this is one where now it can be a little bit hard to solve for. We're going to multiply the X to get it out of the bottom. Oops. And then we're going to divide. By tan 12 to get the answer. So again, you can type tan 12 into your calculator first, or you can do 1,200 divided by tan 12. Okay, you get an answer there, and then of course make sure you write an answer statement. Okay, so let's just keep going and do some more different types of examples. So sometimes in the homework, the questions will look more like the next one where you're sort of given a picture and you can actually draw your triangle right on it. Or sometimes they even give you the question and the triangles are already right on it, similar to this one. So a construction engineer determines a straight road must rise vertically 1.5 meters over a 250 meter distance measured along the surface of the road. And it tells you here, this represents the hypotenuse of the right angle triangle. Calculate the angle of elevation of the road. So as soon as it says angle of elevation, then that means you want to consider a horizontal. Okay, and then it's elevating or rising. Oops. Again, do a better job with a ruler. So we're looking for the angle of how much it's rising by. And then you can complete your triangle. So it says now we have two distances to include. The road must rise vertically 45 meters over. So it's rising vertically. So vertical is up and down. And then it says 250 meter distance measured along the surface of the road. So you can see here the truck is driving. So trucks drive on the surface of the road. But again, read the question carefully because it does say it's the hypotenuse. So the hypotenuse is here. So this is going to be 250 meters. And you can label that height right away. Okay, so now we've got a theta, we've got the hypotenuse, and then if you want to think about what side is this to the theta, it's opposite. So now we have opposite, we have hypotenuse, which means we're going to do sine. This time though, we're looking for the angle. So our x, or our unknown, is the theta. So sine theta is opposite over hypotenuse. We don't know the angle. We just said that was the unknown. So opposite is 45 and hypotenuse is 250. To get rid of sine, or the inverse of sine, oops, is 10.4 degrees. And then, of course, don't forget, this is a word problem, write an answer statement. Okay, so many of the questions have triangles sort of like this, where they kind of give you a clue of what the picture is going to look like, and you just have to kind of fill it in and make a triangle. Okay, so this one, the next one, is sort of the same as well. It talks about, in this case though, we're given two different measurements. So we have to add them together to get the length of one side. So Jackie works for an oil company. She needs to drill a well to an oil deposit. So there's Jackie, the little person there. The deposit lies 2,300 meters below the bottom of the lake. And the lake is 150 meters deep. The well must be drilled at an angle from a site on the land. The site is 1,000 meters away from a point directly above the deposit. So we can, in this picture here, let's just use Jackie as the point that's 1,000 meters away. And then drilled it has to be drilled at an angle. So we want to drill to the oil. That was terrible. Drill to the oil at an angle. What angle is that? That's what we're going to figure out. Okay? So ooh, it's missing the question here. So this time we're going down, which is depression, not elevation. Okay, so we're gonna let theta be the angle of depression. Oops. And when we go, okay, so we have theta. We want to use this side over here, which is going to be the opposite side. However, the opposite side is both, like this whole piece here. So it's 150 plus 2300, which is 2,450 meters. So don't forget to take that into consideration. So that is opposite. And then this side here is adjacent. So again, we've got opposite and we've got adjacent. We're going to use tan. We don't know the angle. We do know the opposite side is 2,450. The adjacent side is 1,000. Divide 2,450 by 1,000 and you get 2.45. And you get 67.8 degrees. Write a little answer statement. It's a little bit messy there if you want me to fix it. Therefore, the angle of depression is 67.8 degrees. Okay, the last example is a tiny, tiny, tiny bit tricky because it's just weird. Unless you're a person who is into orienteering and looking at directions, it's kind of a little bit wordy to try to read the question. So we're going to spend some time on the picture in order to help us, because there are, I think, 2 questions in the homework that look like this. Okay, so if a question gives you an angle as a bearing, so it says as a bearing of 144 degrees, that seems weird because our triangles cannot have angles that big, right? Our right angle triangles, but it means the angle is always measured from the north direction. So if you think about a compass rose, north, south, oops, no, what am I saying? East, south, west, never eat shredded wheat, then that can help you figure out the directions. So a sailboat leaves South Baymouth. I'm going to use SB to represent that. Sails due south to Owen Sound, OS. And of course, now we're going to get our 90-degree angle. At OS, it sails east. So east is in this direction to Tobermory, which I'm going to call TO. There's our right angle. And then it says Tobermory is on a bearing of 144 degrees from South Baymouth, SB. Okay, so you can, it's pretty obvious to fill in our triangle, but we need to know that measure. So what you do to try to figure out what the angle, one of the angles inside the triangle is going to be, then, so when it says bearing, again, one more time, you always measure it from the north. So what this is saying is the north is up here, and then it's on a bearing of 144 degrees to Tobermory. Okay, so if you have a line and this angle is 144 degrees, the total is 180. So then the angle inside the triangle is 180 minus 144, which is 36. Okay, so whenever you do a bearing, then, and it's a weird, like this is an angle larger than it should be in a right angle triangle, then you can just think of it this way. So you look at, okay, if you have north, and you have this line here, this is 180 degrees. This is wherever you're heading to, and then you look at what the bearing says, and then the difference between them, difference between 180 and 144, and whatever the bearing is, will give you the angle inside the triangle. Okay, so, and then we are given some measurements. So it does say that from TO is on a bearing of 144 from SB and a distance of 43 kilometers. So these two are 43 kilometers apart. And then we are looking for how far OS is to TO. Okay, so that's going to be our X. I'm just going to use the short forms OS to TO. Okay, so now we have here, this is the hypotenuse. And then if we're using the 36 up here, then that is the opposite side. So we have opposite and and hypotenuse, which means we're going to use sine. So the opposite is the X, hypotenuse is 43. So this one is a little bit simple. When you have the X in the top, we just want to get rid of the 43. So you multiply on both sides and you get 25.3 kilometers. Okay, so again, be careful when it says bearing. Always think of it from the north direction. And so in these word problem homework questions, not all of these questions are the same. So you want to make sure you take a look at them all so that you can see the different types of questions. Some of them you have to draw a triangle, some of them you have to do bearings. So give them all a try, as many as you can, so that you get a wide variety of different types of word problems. Tomorrow, 8.5, the lesson itself is a little bit shorter, but it actually is now when you have two triangles in your word problem, how you deal with that. Okay, so we're gonna, don't skip, like make sure you do 8.1, then 8.3, and then try 8.5. There's no point in watching the video without doing the homework first. Okay, so give that a try, and if you have any questions,